Hi everyone, welcome to this new topic, Network Application Service. The first point is Common Network Application Service. What are the most common internet services that you use on a regular basis? For most people, the list includes services such as internet searches, social media sites, video and audio streaming, online shopping sites, email, and messaging. Each of these services relies on protocol from the TCP/IP protocol suite to reliably communicate communicated the information between the clients and the servers. Some of the most common services that provide the service are shown in the figure. A brief description of each service is shown in the table. Okay, we can see a router attached to one switch and the switch is attached 6 servers. Protocol and description, domain name system, DNS, resolve internet names to IP addresses. The next is security shell, used to provide remote access to servers and networking devices. The next is simple mail transfer protocol SMTP, send email message and attachment for clients to servers and from servers to other email servers. The next is Post Office Protocol POP, used by email clients to retrieve emails and attachments from a remote servers. The next is Internet Message Access Protocol IMAP, used by email clients to retrieve email and attachment from a remote server. Okay, it's the same POP and IMAP. The next is Dynamic Host Configuration Protocol (DHCP), used to automatically configure devices with IP addressing and other necessary information to enable them to communicate over the Internet. The next is Hypertext Transfer Protocol (HTTP), used by web browsers to request a web page and web servers to transfer the files that make up web page of the World Wide Web. And the last is File Transfer Protocol (FTP), used for interactive files transfer between systems. Finish with check your understanding. Question 1. Which application protocol is used to automatically configure IP addressing information? That is DHCP. Dynamic Host Configuration Protocol is used to automatically configure devices with IP addressing and other necessary information. The next is which application protocols are used by clients to retrieve email message. Choice 2, that is POP and IMAP. That's right, Post Office Protocol and Internet Message Access Protocol are both used by email clients to retrieve emails message. And question 3, which application protocol is used to resolve web addresses to an IP address? That is DNS, which application protocol is used to resolve web addresses to an IP address. Domain name system resolve internet names to IP addresses. The next topic is domain name system. This topic is very important. A note about syntax checker activities. When you are learning how to modify devices configuration, you might want to start in a safe, non-production environment before trying it on real equipment. There are different simulation tools to help build your configuration and troubleshooting skill. Because these are simulation tools, they typically do not have all the functionalities of real equipment. One such tools in the syntax checker. In each syntax checker, you are given a set of instructions to enter a specific set of commands. You cannot progress in syntax checker unless the exact and full command is entered as specified. More advanced simulation tools such as packet tracer, let you enter abbreviated commands, such as you would do on real equipment. Syntax checker, the nslookup command. When you manually configure a device for network connectivity, recall that you also include a DNS server address for home networks. This configuration is typically handled by DHCP running on the home router. Your ISP provider the DNS server address to your home router, and then your home router uses DHCP to send the configuration to all the devices connected to its network. When you type the name for a website such as Cisco, the DNS client running on your device first asks the DNS server for the IP address, such as this address, before sending out your HTTP request. You can use the command nslookup to discover the IP address for any domain name. In this syntax checker activity, practice entering the nslookup command in both Windows and Linux. Okay. From the Windows command prompt, enter the nslookup command to begin a manual query of the named servers. Okay, and we can see the command nslookup, default server, unknown, and address, a local address. The output lists the name and IP address of the DNS server configured in the client. Note that the DNS server address can be manually configured or dynamically learned through DHCP. You are now in nslookup mode. Enter the domain name www.cisco.com. Okay, and we can see enter the domain name and server unknown, the local address, and non-authoritative answer, name, address, alias. The output lists IP addresses related to Cisco. That the server, this is here in the name, that is the server currently has in its database. Notice that IPv6 addresses are also listed. In addition, various aliases are shown that will resolve to Cisco. Enter the exit command to leave nslookup mode and return the Windows command line. Okay, you can directly query the DNS server by simply adding the command name to the nslookup command. Okay, enter this command with the domain name. Okay, you are now working from Linux command prompt. The nslookup command is the same. Enter the nslookup command to begin a manual query of the named servers. Enter enter www.cisco.com to the prompt. Enter the exit command to leave nslookup mode and return to the Linux command line. Okay. As in Windows. Okay. And enter. Okay. You successfully use an lookup command to verify the status of domain names. The next topic is web clients and servers. HTTP and HTML. When a web client receives the IP address of a web server, the client browser uses that IP address and port 80 to request web service. This request is sent to the server using the Hypertext Transfer Protocol. Hypertext Transfer Protocol (HTTP). When the server receives a port 80 request, the server responds to the client request and sends the web page to the client. The information content of a web page is encoded using a specialized markup language. The Hypertext Markup Language (HTML) coding tells the browser how to format the web page and what graphics and fonts to use. HTML is the most commonly used language. Click play in the figure to view a client request for a web page. Okay, okay. The client used DNS to obtain the IP address for the web server request. The client sent an HTTP request to destination port 80. Server sends the HTML web page to the client. Client interprets the HTML and displays the web page for the user. The HTTP protocol is not a security protocol. Information could easily be interpreted by other users as data is sent over the network. In order to provide security for the data, HTTP can be used with Security Transport Protocol. Requests for security HTTP are sent to port 443. These requests use HTTPS in the site address in the browser rather than HTTP. There are many different web servers and web clients available. The HTTP protocol and HTML standard make it possible for the servers and clients from many different manufacturers to work together seamlessly. And we have a packet tracer observe web request. Okay. In this activity, you will observe web requests when a client browser requests web page from a server. Okay. The first point is objectives. View the client-server traffic sent from a PC to a web server when requesting web service. Instruction Part 1. Verify connectivity to the web server. Click External Client and access the command prompt from the Desktop tab. Okay. Click External Client and access the command prompt from the Desktop tab. Okay. Command prompt. Here. This here. Okay, use the ping command to reach the URL Cisco learn. Okay, okay. And notice the IP address included in the ping output. This address is obtained from the DNS server and resolved to the domain name Cisco learn. All traffic forward across a network use source and destination IP address information. Close the command prompt window, but leave the external client desktop window open. Okay. Part 2. Connect to the web server. From the desktop window, access the web browser. In the URL block, type Cisco Learn. Okay. Be sure to read the web page that is displayed. Leave this page open. Minimize the external client window, but do not close it. Okay. Okay. Minimize the external client window but do not close. Okay. Part 3. View the HTML code. From the logical topology, click Cisco LAN Server. Click the Server tab, HTTP tab. Okay. Okay. Service and tab HTTP tab. Then next to index.html file, click Edit. Okay, what? Copyright. Okay. Index. Okay. Edit and compare the HTML markup code on the server that create the web browser display page on the external client. This may require that you maximize the external client window. It's shown when you open the server window. Close both the external client and web server window. Okay. Part 4. Observe traffic between the client and the web server. Enter simulation mode by clicking the simulation tab in the lower right hand corner. Okay. Double click in the simulation panel to unlock it from the PT window. This allows you to move the simulation panel to view the entire network topology. Okay. Okay. View traffic by creating a complex video in simulation mode. From the simulation panel, select Edit Filters. Edit Filters, okay. Click the MISC tab to verify that only the boxes for TCP and HTTP are selected. Okay. Edit all filters. Okay. Only TCP and HTTP. Okay. Add a complex video by clicking the open envelope located above the simulation mode icon. Okay, close and this. Okay, click the external client to specify it as the source. The Create Complex Video window will appear. Specify the Create Complex Video settings by clicking the following within the Complex Video window. Under Video Settings, okay, select Application should be set to HTTP. Okay, select Application HTTP. Click the Cisco LAN serve to specify its destination device. Notice, the IP address of the web server will appear in the description box within the complex video window. Okay, destination address here. For the starting source port, enter 1000. Starting source port. Okay, 1000. Under simulation settings, select periodic interval and type 120 seconds. Periodic 120 seconds. Okay, and create the PDU by clicking the box Create PDU in the Create Complex PDU window. Okay. Observe the traffic flow by clicking play in the simulation panel. Speed up the animation by using the play control slider. When the buffer full window appears, click View Preview Events to close the window. Scroll through the event list, notice the number of packets that travel from source to destination. HTTP is a TCP protocol, and which require connection establishment and acknowledgement of receipt of packets, considerably increasing the amount of traffic overhead. Okay, only a star. Okay, okay, okay. In the first is okay TCP and external client, next remote switch, local web switch, and the web server, web switch, okay, remote switch, okay, external client. Okay, in layer 4 TCP source port, okay, destination port 80 of the web server, layer 3 IP header, source IP is the IP of the external client, and destination IP is the web server. Okay, I close. And this is all for this. See you in the next one. Bye.